placed in an environment will display important parameters such as the quality of the air, the temperature, and the humidity. We utilize the DHT11 component, which consists of the temperature and humidity sensors, the MQ135 component, which consists of the air quality sensor, the I2C OLED display to display environmental readings, the LDR sensor module, which detects day or night based on the brightness of the environment, and the Arduino Nano V3 to connect the sensors and display together. The program would be done with Arduino IDE. Our product is advantageous in regards to the ease of operation of our device to detect whether an environment is safe. By using Arduino IDE, we aim to offer user-friendly solutions to the users. The significance of our product lies in its simplicity and ease of operation, allowing users to swiftly ascertain the safety of their surroundings. Through our collaborative efforts, we seek to contribute to the advancement of accessible, affordable environmental monitoring solutions. By fostering innovation and leveraging open source platforms like Arduino, we aspire to create a positive impact on society by promoting awareness and facilitating informed decision making regarding environmental well-being. Now we will move on to the components of our project.
The main component, one of the component which we have used here is DHT11 temperature and humidity sensor. It is a combined temperature and a humidity sensor. This sensor measures the temperature and the humidity. The output provided by the DHT11 sensor is in digital format.
Don't read so much, only read application.
The accuracy is around plus or minus 2 degrees Celsius for temperature, and for humidity is plus or minus 5% of relative humidity. The range of temperature that the sensor measures is from 0 to 50 degrees Celsius, and for humidity is around 20% to 90% of relative humidity. It works on an operating voltage from 3.3 to 5.5 volts. It has a various set of applications, but it has been mainly used in climate control, weather station, and HVAC system for monitoring temperature and humidity.
Now we will talk about the MQ135 air quality sensor. So this is a sensor that will detect the air quality, and to do this it will measure the concentration of multiple gases such as NH3, NOx, alcohol, CO2, carbon monoxide, and etc. And the output is an analog output which varies based on the detected gases. The accuracy and range also varies depending on the gas being detected, and it typically operates around 5 volts. Now the various applications include being used in monitoring systems. It is mainly used as a smoke alarm or carbon monoxide alarm in your dwellings, buildings, homes, and it is used in environmental monitoring systems.
Here we will talk about the LCD OLED display, which is of 0.96 inches. It uses I2C communication protocol, which is an inter-integrated circuit. It has a resolution of 128 x 64 pixel and uses a monochrome color, which is white or blue. The chip controller is SSD1306, and the OLED display has a viewing angle greater than 160 degree. It has a clear and a bright display. The OLED display works on an operating voltage of 3.3 to 5 volts. The interface is a 4-wire SPI, which is serial peripheral interface, or I2C. The OLED display has already a library which has been developed by Arduino and can be used directly in the programming. It has a various set of applications. The main set is in IoT devices, variables, and small gadgets. It is suitable for displaying sensor data, text, and simple graphics.
The next sensor is LDR sensor. It is a light dependent resistor sensor. It is used to measure ambient light intensity. It has an analog voltage output inversely proportional to the light intensity. The accuracy depends on the sensor quality and the calibration. We can calibrate it to trigger on our desired light levels. It has a typical 10 kilo ohms to few hundred ohms range of resistance, and the operating voltage is generally at 5 volts. Applications are, here we are using it to sense ambient light in our project. It can be used as light sensing application in automated lighting system, sunlight intensity monitoring for solar panel optimization, or it can be used in darkness detection for security systems. The board we are using is Arduino Nano V3. The microcontroller it uses is ATml 80 Mega 328p. The clock speed is 16 MHz. It has 14 digital input-output pins and 8 analog input pins. It operates at a voltage of 5 volts. The input voltage is 7 to 12 volts and the voltage limits are 6 to 20 volts, beyond which it is not operable. It has a 32 kilobyte flash memory and a SRAM of 2 kilobytes and EEPROM of 1 kilobytes. It uses USB, UART, SPI, I2C for communication. It is used for prototyping projects with space constraints and application where lower power consumption is preferred. It is commonly used in robotics, automation and IoT projects. This is the circuit diagram.
And this is the code.